The mass spectrum for ethyl benzoate is shown below. Which fragment represents the base peak? So there's a couple peaks we need to know in a mass spectrum. So one is the molecular ion. So that shows us the mass of the entire molecule. And we usually abbreviate this as M+. And that's often the tallest, the heaviest peak in your spectrum. So that would be this here. This 150 is the M+. And if you were to tally up the molecular weight of ethyl benzoate, you would find out that it weighs 150. And so that's what the molecular ion is. The base peak is the tallest peak. And so this is the most abundant fragment. So this is always set to 100% abundance. So the peak that is at 100% abundance, so it's always set relative to the base peak, so you always have that. This is the base peak. So what that number 150 tells us is that this is a fragment that weighs 105. I said 150, I apologize, that's molecular ion. So this fragment weighs 105 atomic mass units. So you could look at all of these fragments and add up the weight based on their molecular formula. So that would be one way that you could go about this. Another thing that you could do is you can consider, since you have a structure, what has been lost from the molecule. So you could ask yourself, what mass has been lost? And if you do that, you say, okay, 150 was our molecular ion. If we have 105 for our base peak, we subtract that and we know that we lost 45. And so that might give us some hints. Knowing some common fragmentation patterns would also be very helpful. So when you have a functional group, we tend to see alpha cleavage to functional groups. And the reason is that gives us resonance stabilized fragments. So knowing that I'm likely to see fragmentation alpha to this ketone, I might be looking at these groups to see what they weigh. And so the entire benzene ring weighs 77. You could tally that up. It's 6 carbon atoms and 5 hydrogens. On the other side, this ethyl group and the oxygen. Well, the ethyl group is a fragment that you will see a lot, so you might want to recognize that that weighs 29. And then the oxygen, of course, weighs 16. So what that means is that this entire fragment, this OCH3, has a mass of 45. So this base peak is a result of alpha cleavage. So it is cleaving alpha to the carbonyl, and the reason why it is doing that, this is the fragment we'll be left with, is so you can get this resonance stabilized cation. So we would actually end up with this cation structure, and this allows for everything to have a full octet. So this really helps to stabilize this, which explains why this cation is less likely to undergo further fragmentation and more likely to arrive at the detector as it is, which is why we see this in the greatest abundance.